When we talk about deburring and we talk about sheet metal and how it can be sharp on the edges, so we need to deburr it, and especially from any cutting or processing action, drilling, punching, cutting, it creates small burrs. You know, it's easy for us to like take a file and get those burrs off like that quickly and pretty easily with a file. And also we can use some sandpaper to clean it up a little bit so it's not as sharp and there's no burrs and it's a nice smooth edge. That's pretty easy to do with sheet metal. When you start getting into other thicker metals, sandpaper's not going to cut it. Also, files, when you have thicker pieces of metal like this, a file will work, but that's a lot of work to do by hand if you've got a lot of pieces to do. And if you're just getting the burr off, that's okay. You can just use a file to get the burr off quickly. But if you need a smooth, straight edge through the thickness of that material, it's going to take forever to file it. So we've got to use some other kind of process that's going to give us a quicker, easier, better way to do this work and not make it so labor intense with files and sandpaper. Especially when you start getting into really thick pieces of metal that have very jagged cuts, maybe cut on a torch or a plasma cutter, and you need to file and you need to get that edge straight and perpendicular. So there's a lot of work that may have to go into this, and you don't want to do it all by hand. In comes the belt sander. This is only a 1-inch belt sander. It has a 1-inch wide belt on it. There are belts that come in 2, 3, 4, 5, 6, and industrial machines that have big belts that you can put a piece in and it goes in through automatically. This is a machine that we don't really want to use with sheet metal because it's just going to do more damage to the edge of this sheet metal than if we were to just clean it up with some sandpaper and file it real quick. It will do more damage to the metal than good. These machines are for more heavier applications like thicker pieces of metal. When I have a sharp corner on here from cutting it with the hacksaw or some other process, I just want to clean these edges up so they're not so sharp. Maybe get a nice straight edge and perpendicular. These tables are adjustable, and there is a metal backer from here down. So you can see I'm pushing against it in the back and it's solid. Here, up here, there's not. So from here up, it's just belt. This part of the belt is stiff because it has the backer. This part of the belt has some give and it's a little softer. So you're going to do more work pushing it against the solid part than you are here, where it's a little more flexible. You'll be a little gentler with it. That's the reason for the backer. These tables, they're meant to be adjusted. Typically we want them square, and you can check it with a square. Right now that table is square. The table is square to the belt. Typically this is where we want it. However, for certain adjustments you may want a 45-degree grind on it or something, and you can adjust this table for that purpose. And there's just a handle that loosens the table, and then you can swing it down and create an angle to where you maybe want an angle on your sanding or grinding. But typically we're at 90 degrees. So if this is the piece I'm going to just clean up, and I just want to get these sharp corners off around and kind of smooth up the flatness of the edge here. If you look at the edge, and that's even cleaned up a little bit because that's the little piece I just filed. But you can see it's all rough, and there's some burrs here on the corners, and they're sharp on the corners. The other side, same, it's got a saw cut edge. You can see there's some burrs on this corner, and we just want to clean this up. When you're turning on any machine, first of all, I don't like to keep them plugged in for safety reasons. You never know what's going on with these machines. You want to inspect it first. Check out the cord. Make sure there's no cuts or cracks or nicks in it, that there could be an electric short circuit and there could be a fire, or you can get electrocuted. So check out the cord, make sure that there's nothing, no problems with it. And you want to do this periodically through a shop because you never know what happens. Pieces of metal can get thrown around. You never know what can happen in a shop. And pieces of metal could pinch the cord and cut it. So you always want to inspect your equipment. Now, before I just go ahead and plug this in, I want to make sure I check that this machine is off. So here's the power button, and you probably can't see it from there, but this position is on, and that position is off. If you're not positive, talk to your shop supervisor, your teacher, or anybody that knows the machine. If you don't know how the machine works, you shouldn't be using it. You should never go on and turn on machinery or go to use it if you're not familiar with how it works. Okay, so I want to make sure this machine is off. That position is off right there. Now I can plug my machine in. And now I'm going to make sure that the cord and everything is out of the way of any moving parts or my work area. Okay. Now I can't just go and flick this thing on and get to work, because there may be some other issues with the machine. To check that it runs properly, give it a quick turn on and turn off and see how it moves. If it sounds weird, if it looks weird, then stop and either talk to an instructor, or if you know how to repair it yourself, then repair it. But you always want to check, and you can do that by just giving it a quick turn on and turn off real quick. If it seems okay, you can leave it on. One thing you are looking for on a belt sander is how the belt is aligned. There is a wheel that the belt rolls over up top here. This wheel not only keeps tension on the belt, but it aligns the belt left and right as well. So one thing you're looking for when you turn on the machine is how the belt is running on the wheel. If it runs true, like that, straight up and down along the center of the wheel, then you're good. But perhaps it's running off. Like that. Or that way. There's an adjustment that tilts the wheel to make sure that the belt is running true. It could be left or right, off center. You want to make sure that it's running center wheel so that it doesn't tend to want to fly off. Okay, now that we know that the wheel is running true, the machine sounds okay, everything is working appropriately, I think we're ready to use the machine. Whenever you're using a piece of material against a belt sander, a grinder, anything that's creating a force, a downward force toward the table, You never want to stick your part angled down on the table because it's going to want to pull it into the machine. If it gets caught in there, some really bad things can happen when there's all this force going on and there's a piece of stuck metal in the gap down here, and maybe pulls your finger in or something too. So you never want to angle on the table and stick it into the belt. If you need to an angle on your piece of metal, adjust the table like we talked about earlier. You always want to keep your material flat on the table. And then work from one side across. If there are any burrs up here on the metal and it's not cut straight or it has jagged edges, one thing that could happen is as you're going from left to right or right to left, however you're doing it, a piece of that burr could catch the belt and pull on it like this. To make sure that that doesn't happen, you can angle your piece a little bit and run from the middle of the belt over. Or just start going along, and if it does catch, be aware, back off a little, and then lift it up and move it back in, and then come back into the belt. So, a lot of times people say don't use gloves around machinery. Well, it depends on the gloves, depends on the machines. Okay, these gloves are okay, in my opinion, to use around the machines because they're tight fitting to your hands. What you don't want around the machinery is loose articles. A loose flappy glove, strings dangling from a hoodie, hair, earrings, necklaces, headphone strings, anything that's dangling, you should not have dangling on you. It should be off. You should be ready to work and safe. General shop safety. Okay, so I'm just going to clean up the edge of this. So I turn it on, keeping my hands on the metal and on the table. I'm just going to slowly push it in and then move it across. Push it in, just like this. And I'm going to keep going until I get the smooth edge that I want. Okay, now that I got my edge nice and smooth from the belt sander, it's nice and straight now, so it's nice and smooth now, and it should be perpendicular now throughout the thickness of the material. The only problem is the corners are really sharp now. These corners are really sharp because the belt sander pushed all that material down to the corners. So now we have to sand the corner. Well, like I said, you don't want to put it in like this on the table and stick it against that belt sander because it could get caught and pulled into the table down there. However, you can do this angle. You have to just lift it up away from the table. And don't have it down here. Just hold it in your hand. Just like that. corners. Now, that was pretty easy for me to do. Now you can see the corner is nice and cleaned up all the way around too. So there's no sharp edge. It's nice and smooth. It's smooth here. It's perpendicular. No burrs anywhere all the way around. Very good. Good to go. So when you're doing those corners, you have to do it a certain way. To do the corner, you cannot hold the material up this way. The forces that are coming down, if you hold the metal angled up this way, it's going to push it back into your hand. See? But if I have it down this way, I can hold it up against there all day long and nothing will happen because of the way the forces are going. It's just pushing it out a little this way, like this. The problem is when it's this way, the force is coming down, push it towards you and down this way. You want to hold the top and just put the bottom on the sandpaper, and there shouldn't be any problem. It'll be safe and easy to do without anything getting unsafe. So now the other side. So one reason I do use the gloves is because, number one, it gives you good control over the material. Number two, the friction from the sandpaper on the metal gets the metal kind of hot. And if you're holding it and all of a sudden it gets real hot, you're going to drop it, you're going to throw it, you're going to jump, and that makes things more dangerous. So you always want to have control of everything that you're working on in a metal shop. This piece of metal is a little different. I can use this belt sander to clean up this piece of metal. It's a lot bigger than this one, and it's a lot rougher cut because it was cut with a plasma cutter, a handheld plasma cutter. So if I wanted to clean this piece of metal, the cuts aren't perpendicular, they're very jagged, they're not straight. So if I wanted to clean this piece up, I mean, I could use the belt sander, but it's going to take a really long time to clean all that up. It's only going to do a little bit at a time. It's barely doing anything to it. So this would take a very long time to do. You could do it, but it would be a lot of work. So what other machine can I use to actually do a little better job on this? The bench grinder. Okay, the bench grinder, more heavy duty grinding. So I can clean up the edge of this much quicker than I can on a belt sander. Bench grinders use a stone wheel and it spins very fast, and that wheel grinds away at the metal. There's different wheels you can actually get for the grinder, just like the sandpaper is different grits. You can also get wheels that are different grits. So this wheel is fine. The one on here is a coarse. So this coarse one is going to do more work than this medium fine one will. It says right on the box, 8-inch grinding wheel, general purpose, aluminum oxide. That's just what it's made of for common workshop tools. So it's just a general fine grinding wheel. It makes a smoother finish when you're done grinding. The coarse wheels make a little rougher finish when you're done grinding, but they do more work. This wheel over here is actually a Scotch-Brite wheel. The Scotch-Brite wheel is just for finishing. It's not for grinding. It's just for cleaning up metal and making it shiny. So again, you have to check the machinery to make sure it's working properly. Right here, I do not have the machine plugged in, but I'm just checking to see if these two wheels are not moving at the same time, something's wrong. So if it's loose, something's wrong. If I spin it and it makes noise, something's wrong. So just a quick self hand test, making sure it's not plugged in, and it seems to be okay. So then I'm going to check the cord. Check the cord, make sure the cord's okay. Okay, make sure the machine is off. On all machinery, the O is off, the I is on. I don't even know if that's what they are, O and I, but that's what it looks like to me, is off. And I always remember it as off and ignition, but I know that I'm pretty sure that's not what it means. That's just how I remember it. So I got to make sure it's on. That's on. That's off. So I'm making sure it's off before I plug it in. And before I plug it in, I'm going to talk about these tables too, because these tables are adjustable the same way they are on the belt sander, but they work differently. Because it's round and it's a wheel, you cannot square it. You can't put a square against it. It'll never be square. No matter how you set the table, it's not going to be square because it's a curved surface. So the reason this table is adjustable is because when you're putting flat material on there, depending on how thick the material is how you want to adjust your table so that you're kind of centered in the center of the thickness with the curve. Right there, it looks like the table's set to a pretty decent level. But if I were to grind on this piece, it would only be grinding on the bottom. So I might have to adjust the table to accommodate for the thickness of the material. These wheels here are made of stone. If there's a real lot of vibration in here, or anything bad happens in the machine, like a piece of metal getting jammed in there while the machine is running, it could be very dangerous and the stone could explode. That could be very dangerous for us. We always want to make sure that the adjustment on the table, we want it as close as we can get it to the stone without touching. This reduces any chance of material getting caught between the stone and the table. Okay, table's tight, gap is small, angle's decent for the thickness of the material I'm doing. All right, so again, material on the table, and then work it from left to right. With these stones, you don't want to stick the corner of something right into the stone and leave it there. you'll put a big groove into the stone and ruin the whole stone. You want to keep the whole face flat. Making sure I'm off. Cord was checked. Plug in the machine. And I'm ready to go. I just want to check the machine again while the power's on. So when I turn this on, I'm going to quickly the same way turn it on and turn it off to see if it starts spinning correctly. And these shields up here can go down now that I'm ready to start working, just in case there is an accident and something happens where the pieces fly. These shields will protect the user from that happening. You can see through them and see your work. So turn it on and turn it off real quick. Let it build up, turn it off. If there's anything wrong, you'll hear it happening. It seems to be spinning pretty smoothly though right now. Give it a little more. Build it up a little more. It's starting to vibrate at high speed. That's full power. So there is a little bit of vibration, but not a lot. That's it. Now again, flat on the table. Work your piece across the stone, left to right. Go upside down too. If you do it on this side, flip it over and do it on the other side. If any of the metal catches in either the table or on the stone, stop, pull it away, and get a new position. Now this is all just by hand and eye, so you're trying to get a straight line. Don't move it like this. You've got to hold it steady and straight. So now I'm pressing a little bit into the stone and sliding across at the same time, kind of on an angle like this. It's not going back any really, it's just getting the force it needs against the stone to do the work. Now the main point here with this machine is to shape the metal. You're grinding metal because you're removing metal. You want to remove the piece of the metal that you don't want there and get down to a nice straight edge. Then you're going to want to bring it over to the belt sander afterwards, after you get the final shape that you want, to clean up the sharp edges now and clean up the grind a little better. But that is a little better just from grinding it than it was. So we went from that to this. you can round corners and stuff too. So if I needed that corner round instead of sharp and square, I can put it on the table, put it flat, put it up to it, and turn around the corner.